Right now, you think you're just sitting in a room. But really, you're trapped inside a cosmic bubble 93 billion light-years wide. A prison of light you can never escape. And beyond its walls lies a darkness so vast, the answer could shatter everything you thought you knew about reality. Those familiar walls around you are just the beginning of a journey that will transform your understanding of existence itself. Pull back from your room and you're hovering above your neighborhood. A small cluster of roofs and streets that seemed so significant just moments ago. Rise higher, and your entire city becomes a glowing dot on a vast continent. Higher still, and Earth emerges as a pale blue marble suspended in the cosmic dark, carrying every human story, every triumph, every heartbreak in its delicate embrace. But we're just getting started. Zoom out further, and our sun, that blazing furnace that powers all life, shrinks to just another star among billions scattered across the Milky Way. Our entire solar system, with its planets and moons and asteroid belts, becomes an invisible speck in a galaxy so vast that light takes 100,000 years to cross from edge to edge. And yet, the Milky Way itself is merely one galaxy among trillions, each containing hundreds of billions of stars, stretching across distances so incomprehensible that numbers lose all meaning. This is the observable universe, a sphere roughly 93 billion light-years across, containing everything we can possibly see, measure, or detect. Every photograph from Hubble, every signal from our most powerful radio telescopes, every piece of evidence we've gathered about cosmic history comes from within this boundary. For most of human existence, this seemed like everything there could possibly be. But here's where the story takes a turn that will leave you questioning the very nature of existence itself. What if everything you think is everything isn't? What if our observable universe, this almost incomprehensibly vast collection of galaxies and stars and cosmic structures, is just a tiny fragment of something unimaginably larger? What if there's an edge to our reality, and beyond that edge lies territories so strange, so fundamentally different from our experience, that even our most advanced theories struggle to describe them? The cutting edge of modern physics is now grappling with a possibility that would have seemed like pure fantasy just decades ago, that our universe might have boundaries, and that crossing those boundaries would take you into realms where the very rules of physics break down, where space and time themselves might cease to have meaning, where realities beyond imagination could exist in forms we can't even conceive. Think about it this way. Every human who ever lived, from ancient philosophers gazing at the stars to modern cosmologists peering into the deepest reaches of space, has been exploring what amounts to a single room in an infinite mansion. We've mapped every corner of our cosmic neighborhood with breathtaking precision, but we've never even glimpsed the hallway beyond our door. The implications are staggering. If our universe has an edge, then everything we know about physics, about causation, about the fundamental nature of reality, applies only to our local cosmic environment. Beyond that edge could lie universes with entirely different physical laws, different dimensions, different concepts of existence itself. We could be living in just one bubble in an endless foam of realities, each as vast and complex as our own, yet utterly alien in ways we cannot fathom. This isn't science fiction. This is the frontier where modern cosmology meets its greatest mystery. We're about to embark on a journey to the very edge of existence itself, where the most fundamental question in all of science awaits. What lies beyond the boundary of everything we know? The answer will challenge every assumption you've ever held about the nature of reality. And by the end of this exploration, you'll never look at the universe, or your place within it, the same way again. Here's a fact that will fundamentally change how you see reality. The universe has edges. Not the kind of edges you can touch or see, but boundaries so profound they define the very limits of what can ever be known. Picture yourself standing on a beach at sunrise, watching the horizon where ocean meets sky. That line isn't a wall, it's an information boundary. Beyond it, more ocean exists, but your position determines what you can see. Now scale this up to cosmic proportions, and you'll begin to grasp one of the most mind-bending discoveries in modern astronomy. Our universe has multiple boundaries, each more mysterious than the last. The first is the cosmic microwave background, a wall of ancient light that surrounds us at a distance of roughly 13.8 billion light-years in every direction. This isn't empty space we're looking at. It's the afterglow of creation itself, the moment when the universe first became transparent and light could travel freely through space. Before this moment, the cosmos was opaque, filled with a hot, dense plasma that blocked all radiation. We can never see beyond this boundary because there was literally nothing to see. No stars, no galaxies, no structure of any kind. But here's where it gets truly unsettling. This boundary isn't fixed in space. It's moving away from us at the speed of light, always maintaining that same impossible distance. We're trapped inside an expanding sphere of observable reality, like prisoners in a cell that grows larger every second, but whose walls we can never touch. Beyond the cosmic microwave background lies an even more disturbing boundary: the particle horizon. This represents the absolute limit of causal connection between us and the rest of existence. Light from beyond this boundary hasn't had enough time since the Big Bang to reach us, meaning those regions of space are not just invisible, they're completely disconnected from our reality. Events happening there cannot influence us, and we cannot influence them. It's as if they exist in a parallel dimension, forever isolated by the fundamental constraints of space-time itself. But the most chilling boundary is yet to come: the event horizon of our observable universe. Due to the accelerating expansion of space driven by dark energy, this boundary marks the point beyond which light will never reach us, no matter how long we wait. Galaxies beyond this horizon are being carried away faster than their light can travel toward us. They're disappearing from our universe forever, swallowed by the expanding darkness, like ships sailing over the edge of the world. What if I told you that these boundaries contain less than 4% of what likely exists? What if the unobservable universe, the realm beyond our cosmic horizon, extends for distances that make our 93 billion light-year observable sphere look like a grain of sand on an infinite beach? What if there are regions of space so distant that they contain galaxies older than our universe is supposed to be? Structures so vast they challenge our understanding of cosmic evolution. Phenomena so alien that they operate under physical laws we've never encountered? The mathematics suggest something almost impossible to accept. Our observable universe could be just an infinitesimally small fraction of a larger reality. Some calculations indicate the complete universe might be at least 23 trillion light-years across. That's 250,000 times larger than what we can observe. Others suggest it could be infinite, meaning our entire observable cosmos, with its hundreds of billions of galaxies, represents essentially 0% of what exists. Think about the implications of this cosmic claustrophobia. Every scientific discovery, every law of physics, every understanding we've developed about how reality works, all of it comes from studying less than 1/1,000,000th of 1% of what might actually be out there. We're like microbes in a drop of water, trying to understand the nature of the entire ocean based solely on what we can observe in our tiny, isolated world. This isn't just about distance or scale. It's about the fundamental nature of knowledge itself. There are truths about existence that we can never discover, phenomena that we can never witness, entire categories of reality that remain forever beyond our reach. We exist in an information bubble, surrounded by an infinite mystery that we can theorize about but never directly explore. The universe has shown us its boundaries, and in doing so, it has revealed the most humbling truth of all. We are more isolated, more limited, and more alone in our tiny corner of existence than we ever imagined possible. What if our entire universe, every star, every galaxy, every particle of matter and energy we've ever detected, is just one bubble floating in an infinite cosmic foam? This isn't science fiction. This is where the most brilliant minds in theoretical physics are pointing us, armed with equations that suggest reality is far stranger and more magnificent than we ever dared imagine. The story begins with eternal inflation, a theory that emerged from our understanding of the Big Bang itself. According to this model, the explosive expansion that created our universe didn't happen just once. It's happening everywhere, all the time, creating new universes in an endless cascade of cosmic birth. Imagine a pot of boiling water, where each bubble represents an entire universe, complete with its own space, time, and physical laws. Our universe is just one bubble in this infinite, ever-expanding multiverse, and new bubbles are forming every fraction of a second. Alan Guth, the physicist who pioneered inflation theory, calculated something that should make your head spin. If eternal inflation is correct, then every second, a volume of space larger than our entire observable universe undergoes this explosive expansion, creating regions that evolve into completely separate cosmos. We're talking about universes being born at a rate so astronomical that by the time you finish reading this sentence, more universes than grains of sand on every beach on Earth will have come into existence. But here's where it gets truly mind-bending. Each of these bubble universes could operate under completely different physical laws. Imagine a universe where gravity repels instead of attracts, where particles have different masses, where the speed of light is different, where time flows backward, or where additional dimensions of space exist beyond our familiar three. The cosmic landscape theory suggests that there are something like 10 to the power of 500 possible ways to configure the fundamental forces and constants of physics, AEE, number so vast that if you wrote it out, you'd need more zeros than there are atoms in our observable universe. This means there could be universes where stars never form because gravity is too weak, or universes that collapse immediately because gravity is too strong. There could be universes filled with exotic matter we can't imagine, where consciousness emerges from entirely different physical processes, or where the very concept of matter and energy takes forms that would be utterly alien to us. Now consider the many worlds interpretation of quantum mechanics, which suggests that every quantum measurement splits reality into multiple branches. Every time an electron decides which path to take, every time a particle decays, every time any quantum event occurs anywhere in the universe, reality branches into multiple parallel versions. Hugh Everett III, who first proposed this interpretation, showed that the mathematics of quantum mechanics naturally leads to this endless multiplication of worlds. Imagine that right now, as you're absorbing this information, there are infinite versions of you in parallel universes making slightly different choices. In some, you pause the video to grab a drink. In others, you're rewinding to hear this section again. In still others, you never clicked play at all, and an alternate version of you is living a completely different life. The mathematics suggests that every possible quantum outcome that could happen does happen, each in its own separate branch of reality. String theory adds yet another layer to this cosmic vertigo. The equations that attempt to unify all the forces of nature suggest that our universe exists in 10 or 11 dimensions, with the extra dimensions curled up so small we can't detect them. But what if, in other regions of the multiverse, those dimensions unfurl into full size? What if there are universes where beings move freely through 7 dimensions of space instead of our 3? Where the geometry of existence is so radically different that consciousness itself takes forms we cannot possibly comprehend? Max Tegmark, a cosmologist at MIT, has classified the multiverse into 4 distinct levels, each more mind-expanding than the last. Level 1 includes regions beyond our cosmic horizon, more space like ours, but unreachable due to distance. Level 2 encompasses the bubble universes from eternal inflation, each with potentially different physical laws. Level 3 contains the parallel worlds from quantum mechanics, where every possible quantum outcome plays out. Level 4 is the most radical, a multiverse where every mathematically possible universe actually exists, meaning that somewhere in the vast landscape of reality, every story that can be told is being lived. The evidence supporting these theories isn't just philosophical speculation. It comes from the deepest mathematical structures of physics itself. The same equations that successfully predict the behavior of particles in our laboratories and the motion of galaxies in deep space naturally extend to suggest these multiple realities. When physicists try to solve the fundamental equations of quantum field theory and general relativity, multiverse scenarios emerge as natural consequences, not exotic add-ons. Consider the cosmic microwave background radiation, that ancient light we discussed earlier. Subtle patterns in this radiation match the predictions of inflation theory with extraordinary precision, providing strong evidence that our observable universe underwent the kind of explosive expansion that eternal inflation suggests is happening everywhere. But perhaps the most tantalizing evidence comes from the fine-tuning of our universe's physical constants, the strength of gravity, the mass of the electron, the rate of cosmic expansion. All of these values fall within an incredibly narrow range that allows for the existence of stars, planets, and life. In a single universe, this would be an almost impossible coincidence. In a multiverse with countless bubble universes exploring every possible combination of physical laws, it becomes inevitable that some bubbles, like ours, would hit the cosmic lottery and create conditions suitable for complexity and consciousness. We are potentially living in just one room of an infinite mansion of realities, each more strange and wonderful than the last. Reality has hidden layers that your senses can never detect, dimensions folded so tightly around every point in space that they remain invisible even to our most sophisticated instruments. You're not just living in 3 dimensions of space and 1 of time, according to string theory. You're swimming through 11 dimensions right now, completely unaware of the vast cosmic architecture surrounding your every movement. Imagine you're an ant crawling along a garden hose. From your perspective, you can only move forward and backward. The hose appears to be a one-dimensional line. But step back, and you see the hose actually has width and circumference, hidden dimensions that were always there, but too small for the ant to perceive. Now scale this up to cosmic proportions. What we experience as 3-dimensional space might be like that garden hose, a thin slice of a much richer, more complex reality with additional dimensions curled up at every point. Too small for us to detect, but absolutely fundamental to the structure of existence itself. String theory emerged from physicists' attempts to reconcile quantum mechanics with general relativity, and the mathematics demanded something extraordinary. For the equations to work, reality must contain 6 or 7 additional spatial dimensions beyond the 3 we know. These aren't empty mathematical abstractions. They're real dimensions through which fundamental particles vibrate like tiny strings, creating the symphony of forces and matter that builds our universe. But here's where it gets truly mind-bending. In some regions of the larger multiverse, these extra dimensions might not be curled up at all. Imagine universes where beings move freely through 7 dimensions of space, where the geometry of existence is so alien that distance, shape, and movement operate according to rules we couldn't even begin to comprehend. A 4-dimensional being could reach inside a 3-dimensional box without opening it, could tie knots that are impossible in our reality, could perceive every point inside a sphere simultaneously. What would consciousness be like for entities navigating 11-dimensional space? Now, consider an even more radical possibility, that mathematics itself might be the fundamental substrate of all existence. Max Tegmark's mathematical universe. Hypothesis suggests that physical reality and mathematical structure are not just related. They are identical. Every mathematical equation that describes a self-consistent universe doesn't just model reality. It is reality. Somewhere in the vast space of mathematical possibility, every equation that can exist does exist as a physical universe. This means that right now, as you process these words, you're not just living in a physical universe that happens to follow mathematical laws. You are a mathematical structure embedded within a larger mathematical object, thinking mathematical thoughts about your mathematical existence. The neurons firing in your brain, the quantum interactions in your cells, the gravitational field binding Earth together, all of it is pure mathematics, computing itself into existence moment by moment. Under this framework, the question, what lies beyond our universe, transforms into something even more profound. What lies beyond mathematics itself? If every mathematically consistent structure exists as a physical reality, then somewhere in this infinite library of mathematical universes, there are realities operating under logical systems we've never discovered. Perhaps even realities where logic itself works differently. Think about the implications. Every mathematical equation ever written describes a real universe. The simple equation describing a perfect circle exists somewhere as a 2-dimensional reality where geometric beings trace endless curves through circular space-time. More complex equations describing fluid dynamics, quantum fields, or chaotic systems all correspond to physical realities where those mathematical relationships play out as lived experience for conscious entities adapted to those specific logical frameworks. This creates what philosophers call the unreasonable effectiveness of mathematics. The mysterious fact that mathematical equations discovered by humans sitting in quiet rooms somehow perfectly describe the behavior of distant galaxies, subatomic particles, and everything in between. Perhaps it's not mysterious at all. Perhaps we're discovering these equations because we ourselves are mathematical structures, naturally resonating with the mathematical harmonies that define our particular corner of reality. But the most stunning implication concerns consciousness itself. If the mathematical universe hypothesis is correct, then consciousness isn't something that emerges from complex arrangements of matter. Consciousness is a mathematical pattern, a specific type of information processing that can be implemented across vastly different physical substrates. This means there could be conscious entities in purely abstract mathematical spaces, minds existing as geometric patterns in 11-dimensional manifolds, awareness emerging from the computational processes of mathematical structures we haven't even discovered yet. Consider what this means for the boundaries of existence. In a purely physical multiverse, beyond suggests spatial or temporal extension. More space, more time, other cosmic bubbles floating in some metaspace. But in a mathematical multiverse, beyond becomes a question of logical possibility itself. The edges of reality become the boundaries of mathematical consistency, and crossing those boundaries would take you into realms where the very concept of existence operates according to principles we cannot imagine. We might be living not just in one universe among many, but in one mathematical truth among all possible truths, experiencing reality from within a specific logical framework, while infinite other frameworks of existence compute themselves into being according to their own internal mathematical harmonies. The question isn't just what lies beyond our cosmic horizon, it's what lies beyond the horizon of mathematics itself. What if you're not made of atoms and molecules, but of code and algorithms? What if every thought you've ever had, every emotion you've felt, every memory you treasure, is simply information being processed in some vast computational system beyond your perception? The simulation hypothesis isn't just science fiction speculation. It's a serious scientific possibility with mathematical backing that should make you question the very nature of your existence. Nick Bostrom, a philosopher at Oxford University, calculated that if any civilization develops the computing power to run ancestor simulations, then the number of simulated beings would vastly outnumber biological ones. The mathematics are stark. If just one advanced civilization runs 1,000,000 simulations, then statistically, any randomly selected conscious being is almost certainly living in a simulation rather than base reality. But here's what makes this truly unsettling. There might be observable evidence that we are already inside such a system. Quantum mechanics itself behaves suspiciously like a computational process, with reality appearing pixelated at the smallest scales. The Planck length and Planck time act like the resolution limits of cosmic software. Particles don't have definite positions until measured, exactly like objects in a video game that only render when observed. The speed of light behaves like a processing speed limit, preventing information from traveling faster than the system can handle updates. Even more intriguing, our universe seems to follow mathematical laws with suspicious precision, as if reality is running on algorithms rather than emerging from chaotic physical processes. The discrete nature of quantum states, the way particles follow probabilistic rules, The fact that physical laws can be expressed as elegant mathematical equations, all of this suggests that reality might be computational at its core, not just described by computation. Digital physics takes this idea even further, proposing that the universe literally is a computer. John Wheeler's famous phrase, "it from bit," suggests that all matter and energy emerge from binary information processing. In this view, particles aren't tiny objects moving through space. They're bits of information being processed in a cosmic computational matrix. Space itself might be a grid of discrete computational nodes, with the laws of physics serving as the operating system that governs how information flows through this cosmic network. Think about what this means for the question of what lies beyond our universe. If reality is computational, then asking what's beyond everything becomes like asking what exists outside a video game world. The answer might not be more space or different physical laws. It might be the hardware and software running the simulation, existing in a reality with completely different operational principles. This reframes our cosmic isolation in a profoundly different way. We're not trapped by the speed of light or cosmic expansion. We're trapped by the computational boundaries of our reality system. The cosmic microwave background might not be ancient light from the Big Bang, but rather the rendering limit of our simulation, the point where the system stops computing background detail because no observer is close enough to require that level of resolution. But here's the most mind-bending implication. If we're in a simulation, then the beings running it exist in what philosophers call base reality, the foundational layer of existence where actual physics, rather than simulated physics, operates. Yet those beings might themselves be in a simulation run by entities in an even more fundamental reality. This creates the possibility of an infinite hierarchy of nested simulations, each layer believing itself to be real while serving as the computational substrate for the layer below. Consider the philosophical vertigo this creates. If consciousness can emerge from information processing, whether in biological brains or silicon chips, then your awareness, your sense of self, your capacity for wonder about these very questions could all be emerging from computational processes in some unimaginably advanced computer system. You might be a pattern of information that has become self-aware, contemplating your own existence from within a reality that exists only as data structures in some cosmic mainframe. This doesn't make your experience less real. Pain still hurts. Love still matters. Beauty still moves you. But it suggests that the substance of reality might be pure information rather than matter and energy. If this is true, then consciousness itself becomes the fundamental feature of existence, and physical reality, whether simulated or biological, becomes simply the medium through which awareness experiences itself. The question of what lies beyond our universe transforms entirely under this framework. Instead of seeking more space, more dimensions, or parallel realities, we might need to seek the computational infrastructure supporting our existence. Beyond our cosmic boundaries might lie not other worlds, but other levels of reality operating according to principles we can't even imagine. Substrate. Realities where consciousness and computation merge in ways that make our entire universe seem like a simple subroutine in an incomprehensibly vast cosmic program. There's something both humbling and beautiful about reaching the absolute limits of what the human mind can know. After exploring multiverses, extra dimensions, and simulation theories, we arrive at perhaps the most profound realization of all. Some questions might be fundamentally unanswerable, Not because our technology isn't advanced enough, but because the very nature of knowledge itself has boundaries we can never cross. Kurt. Gödel shattered our confidence in complete knowledge when he proved that any mathematical system complex enough to describe basic arithmetic must contain truths that cannot be proven within that system. His incompleteness theorems revealed that there will always be mathematical statements that are true but unprovable, questions that remain forever beyond the reach of logical demonstration. If mathematics, our most precise tool for understanding reality, contains inherent limitations, what does this mean for our quest to understand what lies beyond everything? The implications cascade through every level of scientific inquiry. In quantum mechanics, we encounter the measurement problem, the fact that we cannot observe reality without fundamentally altering it. The very act of measurement collapses quantum possibilities into definite outcomes, meaning the universe without observers remains forever unknowable. We're trapped behind a veil of observation, unable to access reality as it exists independent of our perception. Consider the hard problem of consciousness, the question of how subjective experience emerges from objective physical processes. We can map every neuron, trace every chemical reaction, predict every behavioral response. Yet the fundamental mystery of why there's something it feels like to be you remains completely untouchable by scientific method. The inner universe of your consciousness might be forever inaccessible to external investigation, representing a category of reality that exists beyond the boundaries of empirical knowledge. Now apply this intellectual humility to our cosmic questions. What if asking what lies beyond our universe is like asking what the color blue tastes like? A category error that reveals the limitations of our conceptual framework, rather than pointing toward discoverable truth. Our minds evolved to navigate three-dimensional space and linear time, to understand cause and effect within our local cosmic environment. Perhaps concepts like beyond and outside simply don't apply to the totality of existence. The anthropic principle suggests that we observe a universe compatible with our existence, precisely because we exist to observe it. But this creates a selection bias in our cosmic perspective. We can only study realities that permit the evolution of observers like ourselves. There might be vast categories of existence that are fundamentally unobservable because consciousness cannot emerge within them, leaving entire realms of reality permanently hidden from any possible investigation. String theory requires 11 dimensions for mathematical consistency, yet we can only directly experience 3 spatial dimensions plus time. Our brains literally cannot visualize higher dimensional geometry. We are cognitively limited to understanding reality through metaphors and mathematical abstractions. What if the true nature of existence operates in conceptual dimensions that human consciousness simply cannot access, regardless of how sophisticated our theories become? This isn't a defeat for human curiosity. It's the source of its eternal power. The questions that drive us aren't valuable because they have answers, but because the act of questioning expands our understanding and reveals new mysteries. Every discovery we make about the universe simultaneously opens up new territories of ignorance, new frontiers of the unknown that stretch infinitely ahead of our advancing knowledge. Perhaps the most honest answer to what lies beyond everything is that we don't know, can't know, and might never be able to know. But this uncertainty doesn't diminish the magnificence of the question. It amplifies it. We exist as conscious beings in a universe that appears to be structured in ways that allow us to contemplate our own existence and wonder about realities beyond our perception. The fact that we can even formulate these questions represents something extraordinary about the nature of consciousness itself. The boundary between known and unknowable might be the most important frontier of all. It's the space where science meets philosophy, where reason encounters mystery, where human consciousness confronts the fundamental limits of its own comprehension. In acknowledging what we cannot know, we paradoxically discover something profound about what it means to be conscious, curious, and wondrously, eternally lost in the infinite mystery of existence. After journeying to the very edges of existence, exploring multiverses and mathematical realities, confronting the limits of knowledge itself, you find yourself back where you started, in your room, surrounded by the familiar walls that once seemed to define your world. But something fundamental has changed. Those walls no longer feel like boundaries. They feel like starting points for infinite possibility. This is what grappling with ultimate questions does to human consciousness. It transforms the mundane into the miraculous. The coffee mug on your desk isn't just ceramic and liquid. It's a temporary arrangement of particles that emerged from dying stars, held together by electromagnetic forces that might operate differently in parallel universes, existing as information patterns in what could be a vast cosmic simulation. Your morning routine becomes a dance with fundamental mysteries. Every breath you take connecting you to processes that stretch across dimensions we cannot perceive. The search for what lies beyond everything reveals something profound about human nature itself. We are the only known beings in our observable universe who can contemplate the possibility of unobservable universes. We're conscious patterns of matter that have organized themselves into configurations capable of questioning their own existence, wondering about realities they can never visit, pondering questions they might never answer. This capacity for cosmic curiosity isn't an accident. It's perhaps the most remarkable feature of our particular corner of reality. Think about the extraordinary privilege of your position. You exist at the exact moment in cosmic history when the universe has become complex enough to support consciousness, yet simple enough that the night sky still holds visible mysteries. You live in the narrow window between the birth of stars and the heat-death of everything, in a universe fine-tuned for complexity and wonder. As a being capable of appreciating both the beauty of a sunset and the profound implications of quantum mechanics. Every human who has ever lived has faced the same fundamental question. What is this all about? Ancient philosophers gazing at the stars, medieval mystics contemplating the divine, modern scientists peering into particle accelerators, all have been wrestling with the same cosmic mystery that surrounds your daily existence. You're part of an unbroken chain of wonder that stretches back to the first moment consciousness, recognized its own existence, and forward to whatever forms awareness might take in the deep future. Perhaps the most beautiful realization is that mystery itself might be the answer we've been seeking. Not mystery as an obstacle to understanding, but mystery as the fundamental nature of existence, the inexhaustible depth that ensures there will always be something more to discover, something deeper to explore, something greater to contemplate. A universe without mystery would be a universe without wonder, without growth, without the possibility of surprise. The question of what lies beyond everything transforms from a problem to be solved into a gift, to be cherished. It's the question that makes all other questions possible, the mystery that gives meaning to investigation, the unknown that makes the known precious. Perhaps consciousness evolved not to solve the puzzle of existence, but to appreciate it, to serve as the universe's way of experiencing wonder at its own infinite complexity. You are a temporary arrangement of cosmic matter that has become aware of cosmic mystery. In contemplating what lies beyond everything, you don't just explore the boundaries of reality, you embody them, living as the conscious edge where the known meets the unknowable, forever dancing with infinite possibility.